When I was a kid, I was completely obsessed with flight. I had encyclopedias of aircraft, I argued with my friend who thought the Saturn V was cooler than the space shuttle, I had a subscription to Aviation Week. If that doesn't speak volumes about my childhood, I don't know what does. But without a tangible connection to the sky growing up, these interests were just ideas in my head. I never lost interest in space, but going through college, my attachment to the aerospace industry grew more and more faint, until NASA Social happened to me. NASA Social is a program where people with voices on non-traditional platforms are invited to go behind the scenes at NASA and see firsthand the efforts of the people who make space exploration possible. I had the privilege of witnessing my very first launch through this program in 2015, and basically overnight I went from asking Elon who to what kind of control and optimization algorithms does SpaceX use to guide a 70-meter tall 9-ton booster falling from the edge of space to a zero-velocity touchdown on a floating ship at sea. It was seriously that transformative for me. And so when I had the chance to return to KSC for another NASA Social event, I jumped at the opportunity. On a chilly Monday morning in December, I made my way to the Kennedy Space Center. Top down, of course. I'd rented a Mustang for this trip and I was determined to make the most of it. But I was mainly here for two things, the rocket and the science. Let's start with the science, since without that, there's no reason to have a manned space program. CRS-13 was a resupply mission for NASA contracted to SpaceX. Its objective was to deliver 4,800 pounds of food, water, and experiments to the ISS. A lot of people know about the first two payloads, very few have a good grasp of the latter. But it's important, so let me touch on some of the experiments going up that I found interesting. The optical fiber production in microgravity experiment is an investigation spearheaded by a private company called Made in Space. They're looking to see if fiber optic cables, made in space, perform better than those made on Earth. Disturbances from things as benign as gravity-driven convection during crystallization of nanometer-scale particles can result in poorer quality glass. Low Earth orbit might actually be the best place for us to make high-performance fiber optics. And that could lead to faster internet and YouTube, which makes this research well worth it in my opinion. NASA's Total Inspectral Solar Irradiance Sensor, aka TSIS-1, is an observation platform that will record precise data on the distribution and intensity of solar radiation from its perch on the ISS. This data forms the baseline for modeling everything from upper atmosphere compositions to climate patterns. Weather, solar power, the ozone layer, none of it can be studied without knowing exactly what the sun is emitting at any given time. The space debris sensor is basically an instrumented drum. Membrane layers and instruments, including acoustic sensors, measure when, where, and how the SDS is struck by small-scale debris. We're talking like paint chips and grains of sand, stuff that the Space Surveillance Network can't track. We know it's out there, but until we characterize this kind of debris, we can't even begin to estimate how much of it is out there or what kind of risk it poses to spacecraft. Launchpad Medical is running a test on their new biocompatible bone adhesive called Tetranite. It acts as both a bonding agent and a scaffold for bone growth. To show that it works though, you need to demonstrate that osteoblasts are compelled to mineralize bone material in the absence of a biomechanical incentive like gravity. Prove this and you just might have a new tool to counter things like broken bones in space or osteoporosis on the ground. Alright, I butchered enough cutting-edge research for one day, let's get on to the rockety things. First off, no visit to the Kennedy Space Center is complete without a stop in the granddaddy of all rocket cathedrals, the Vehicle Assembly Building. Over 500 feet of vertical space for integration of the Saturn V, the Space Shuttle, and soon the Space Launch System, or SLS. Do I have any Pacific Rim fans out there, or am I the only one that likes that movie? A standing Jaeger would reach about here. The VAB is that big. Currently residing in the VAB are a mobile launcher platform that once cradled space shuttles, and a mass and fit check simulator for the Orion space capsule. Another cool stop was Pad 39B, one of the former launch pads for the Apollo and Space Shuttle programs. I was here 3 years ago when the pad was stripped down and naked without any of its thermal protection tiles. In the time since my last visit, NASA reinstalled those thermal tiles, installed a new flame deflector, and also installed a sound suppression system. Unlike the Space Shuttle, the SLS will have all of its thrust diverted in a single direction, and the design of that flame deflector required the use of NASA's fancy supercomputing capabilities over at NASA Ames. And of course, while I was here, I couldn't resist taking a peek over at Pad 39A, where SpaceX was working frantically to prepare for the inaugural launch of the Falcon Heavy. Unfortunately, the doors to the horizontal integration facility were sealed shut, so I couldn't sneak a peek at the Fat Falcon. But there was a Falcon I could take a look at, and that was the CRS-13 rocket. I had been looking forward to this opportunity for weeks. This was the glorious piece of hardware that would launch all of the research that I'd previously mentioned and more to the ISS. Both the first stage booster and the Dragon capsule here had been flown on previous missions. You can even see some of the soot on the booster that hadn't been fully cleaned off. This was the most recycled rocket SpaceX had ever assembled. And on top of that, this launch was extra special because it was going to be the grand reopening of Pad 40, which had previously been damaged by a fueling mishap over a year ago. SLC-40 was also the pad where I'd seen my first launch, so yeah, I was really rooting for this launch to work out. The timing of our visit was honestly perfect. With the sun setting in the west, the rocket was backlit and the silhouette of the airframe was just stunning. You can see near the capsule a mobile clean room. This is where late loading of the Dragon cargo capsule happens. Time-sensitive payloads like animal experiments are always stowed in the last 24 hours before launch. I was soaking in the whole experience. I tried to get a glimpse of the engine bells or telltale serial number for Booster 35, I admired the aluminum grid fins which they're still using on older Falcon 9 variants, and then after a group picture, our time was up. We piled back into the bus and retreated to our hotels. That night, news came down via the Twitter grapevine that SpaceX was postponing their launch. Tuesday's NASA social agenda had already been set though, and we had tours lined up for us, so I pushed back my flight to late Wednesday and spent Tuesday morning seeing some more of KSC. I got to walk the same ramp where astronauts had walked before me, peeked inside a fire control room, and I got a glimpse of KSC's prototyping playground. Have a listen to our guide's narration.
R&D work is all done in right there. We got some of the most high-tech machine work done inside there, CNC machines, stuff like that. And they really do, they produce some good stuff. We had some pieces and parts that got shipped to us from vendors for the space station that were damaged in shipping. We had to remanufacture right there.
The things I would do to take a peek inside. And then, at the end of our second day, we heard that SpaceX was pushing back the launch again. SpaceX found evidence of contamination inside the fuel tank of the second stage. They wouldn't be ready for another attempt until Friday. I was more than ready to call my boss and say I wasn't coming home until I saw a launch, but I also had Christmas gifts to make for people. I don't mind putting my job on hold, but I draw the line at letting my friends down. They asked me to make things for them, and I agreed. I never got a chance to use the tripod stabilizing hook that I'd fabricated specifically for this launch opportunity. Was it disappointing? Absolutely. CRS-13 had already been postponed 2 times before I'd even gotten to Florida. I was disciplined enough to hold off on buying plane tickets until the absolute last minute, so those delays hadn't affected my travel plans. I thought I'd weathered the worst of the setbacks, but clearly I'd been outmaneuvered by Mr. Murphy. This isn't the conclusion to my grand NASA adventure that I was hoping for, but it is the honest one. Rocket science is hard, and nothing can be taken for granted in this world. CRS-13 launched on the morning of December 15th, successfully ferrying its payload of food and science to America's sole national lab in space. About 2 weeks from now, the Dragon capsule that carried the supplies will be loaded with the results of dozens of experiments for analysis by people on the ground. It was seriously cool to have been able to meet some of the men and women working to advance our knowledge and reach in space, and I can't wait until I have the opportunity to do it all again. Hopefully with a rocket launch this time. Thank you all very much for watching.